Hi, it's Richard here again, and welcome to my YouTube channel. Today, our discussion on calculus will be on hyperbolic functions. In our last video, we talked about the derivative of cyclic functions. If you have not watched that video, please check it out on YouTube. Today, before the lesson will end, I will introduce you to hyperbolic functions. Then we'll talk about the identities and the connections of the identities involved in hyperbolic functions. Then, if there is time, we'll talk about the derivative of hyperbolic functions. This will be a very interesting engagement, so please come with me. So last, we said I want to talk of cyclic functions. Then we are talking about the function of a circular trigonometric identity. So hyperbolic functions talks about the function of a curve rather than a circle. So the hyperbolic function of a function, let's say x, includes sin x, cos x, tan x, sec x, cot x, and cosec x. The difference between hyperbolic and cyclic function is that a cyclic function talks about a complete circle, but hyperbolic talks about a curve, an arc, or any other thing that is not a full circular graph. So the identities, you see that when we are talking about cyclic function, we say sin x. But this one, we just add the h to the sign to have sin x. Then this is the same thing, cos x, tan x, sec x, cot s, and cosec s. So now, I will tell you what these represent, and they are trigonometric identities and connections. So come with me. So, when we talk of sin x, is having this identity. Please, there is a way of proving this, but for the sake of time, if we talk of sin x is equal to e, the exponential function e exponent x minus e exponent negative x over 2. Then cos s is equal to e exponent x plus e exponent negative x all over 2. So this is e exponent x minus e exponent negative x all over 2. Then this is e exponent x plus e exponent negative x all over 2. So we can find our tan x. So we know that from our cyclic functions, we know that tan is equal to sine over cos. The same way in hyperbolic function, tan is equal to sin x over cos s. So what is our sin? Our sin x is this, is e exponent x minus e exponent negative x all over 2. That's for sin. All over cos. Cos is e exponent x plus e exponent negative x all over 2. So we can rewrite this function as e exponent x minus e exponent negative x all over 2, then divided by e exponent x plus e exponent negative x all over 2. So this can be rewritten as e exponent x minus e exponent negative x over 2 times our reciprocate 2 over e exponent x plus e exponent negative x. So these two divide that, will be left with e exponent x minus e exponent negative x all over e exponent x plus e exponent negative x. Then we can say that this is tan x. So the identity for tan is this. So we know that of sin x to be e exponent x minus e exponent negative x over 2, and cos x to be e exponent x plus e exponent negative x over 2. Then tan x is e exponent x minus e exponent negative x all over e exponent x plus e exponent negative x. Please take notice of it. Now we'll look at the other identities, what their value is and their relationship with this. So the next one is sec x. So we know that sec in cyclic function is the inverse of cos. The same way these two is the inverse of cos. So we say this can be written as 1 over cos x. So this will be equal to 1 all over, what's our cosh? Cosh is e exponent x plus e exponent negative x all over 2. So we can rewrite that as 1 divided by e exponent x plus e exponent negative x over 2, which we can change to multiplication problem 1 times 2 over e exponent x plus e exponent negative x. So this will be equal to 2 all over e exponent x plus e exponent negative x. Then this becomes sec x. So please, this is the identity for sec x. Take notice of it. So the next one we'll talk about is cos x. So we know that cos x in cyclic function, cot is the inverse of tan. The same way in hyperbolic, cos x is the inverse of tanh. So we say 1 over tanh x. So if tanh x is sin x over cos x, then we can say 1 over tanh x will be equal to cos x over sin x. We know cos x to be this, sin x to be that. We substitute and get the identity for this. So cos x will be e exponent x plus e exponent negative x over 2. I can say divided by, since it is divided by e exponent x minus e exponent negative x over 2 for sin. We can rewrite that as e exponent x plus e exponent negative x over 2 times 2 over e exponent x minus e exponent negative x. This can divide that. What is left? We'll be left with e exponent x plus e exponent negative x all over e exponent x minus e exponent negative x. Then this becomes the identity for cos x. Please take notice of it. Yeah, the next one we'll talk about is cosec x. When we're doing cyclic functions, we said that cosec is the inverse of sine. The same way, cosec is the inverse of sin. So you can say this is 1 over sin x. What is sin? Sin is this. So you can say this is 1, since it is divided, I will say divided by e exponent x minus e exponent negative x over 2. That's sin. We can rewrite this as 1 times 2. I'll reciprocate e exponent x minus e exponent negative x. What are we having in our share? We have 2 all over e exponent x minus e exponent negative x. Then this becomes the identity for cos x. I hope you get that. So we're able to establish the identity for all. Sin x is e exponent x minus e exponent negative x over 2. Cos x, e exponent x plus e exponent negative x over 2. Then tan x is equal to e exponent x minus e exponent negative x all over e exponent x plus e exponent negative x. Then sec x is equal to 2 over e exponent x plus e exponent negative x. Cos x is equal to e exponent x plus e exponent negative x all over e exponent x minus e exponent negative x. Then cosec x is 2 all over e exponent x minus e exponent negative x. Please, this is a very, very important. So please take notice of them because we'll be using them as time progresses. The next thing we'll talk about is we establish the identity and the relationship between all these three functions. So come with me. So now we want to establish some relationship between the hyperbolic functions. Now I want to square this. See, cos square x. I want to find cos square x. So it means e exponent x plus e exponent negative x over 2 all square. So I can rewrite this as e exponent x plus e exponent negative x square over 2 squared, which is 4. I can expand this to be e exponent x plus e exponent negative x in one bracket, then e exponent x plus e exponent negative x in another bracket, all over 4. Now let's multiply. E exponent x times e exponent x. See, this is indices. We are going to use indices. Indices is saying that when two indices are multiplying with the same base, we add the exponent. So e exponent x times e exponent x will be e exponent 2x. I hope you get that. That's e exponent x plus x. Okay, so e exponent x here times e exponent x here will be e exponent 2x. Then e exponent x times e exponent negative x. That will be e exponent, that will be, come with me, that will be e exponent x times e exponent negative x will be e exponent x plus negative x. That will be e exponent x minus s, and it's e exponent 0. E exponent 0 is nothing but 1. So let's go. So this e exponent x times e exponent negative x will be e exponent 0. E exponent negative x times e exponent s will be e exponent 0. Then e exponent negative x times e exponent negative s will be e exponent negative 2x all over 4. So what do we have? We can group like terms. We have e exponent 2x plus e exponent negative 2x. E exponent 0 is 1, so plus 1. E exponent 0 is 1 plus 1 all over 4. So when we simplify that further, we get e exponent 2x plus e exponent negative 2x plus 2, 1 plus 1 is 2, all over 4. Then this becomes our cos square x. So we're able to establish an identity for cos square x. Now let's find sin square x. So our sin square x will be equal to, we'll square this, e exponent x minus e exponent negative x all over 2 all square. So we have e exponent x minus e exponent negative x all square, then 2 square is 4 again. So what are we having? We have e exponent x minus e exponent negative x in one bracket. Expanding this, we have e exponent x minus e exponent negative x in another bracket all over 4. So let's try expanding. So e exponent x times e exponent x will be e exponent 2x. E exponent x times this, that will be e exponent minus e exponent 0. This times this also minus e exponent 0. And this times this will be plus e exponent negative 2x all over 4. So what are we having? On group it, we have e exponent 2x plus e exponent negative 2x. Then e exponent 0 will be 1, so minus 1. E exponent 0 will be 1, so minus 1 all over 4. So we have e exponent 2x plus e exponent negative 2x minus 2 all over 4. Then this becomes sin square x. We are trying to establish an identity, so please take notice of it. Okay, so now we establish the identity for cos square x and sin square x. Let's try to subtract them. So we have cos square x minus sin square x. So it will just be this minus that. So we have e exponent 2x for this minus e exponent negative 2x, then plus 2. So when we prove this place was plus, so please let's take notice of it. It was plus. So we said plus e exponent 2 e exponent 2x plus e exponent negative 2x plus 2 all over 4 minus this e exponent 2x plus e exponent negative 2x minus 2 all over 4. So now you realize that they have the same denominator. We just repeat one and simplify the numerator. So let's try to expand this. So we have e exponent 2x plus e exponent negative 2x. So I'll repeat them, just bring one of the denominators. So plus 2 minus e exponent 2x minus e exponent negative 2x plus 2. So the negative will affect that, will get plus 2 all over 4. So let's group like terms. So I have e exponent 2x minus e exponent 2x plus e exponent negative 2x minus e exponent negative 2x, then plus 2 all over 4. So realize that e exponent 2x minus e exponent 2x will be 0. E exponent negative 2x minus e exponent negative 2x is 0. Then 2 plus 2 is 4. 4 over 4 is nothing but 1. So we can conclude that our cos square x minus sin square x is nothing but 1. Remember, in cyclic function, cos square x plus sin square x is equal to 1. By hyperbolic function, cos square x minus sin square x is rather equal to 1. So please take a very good notice of them. There are slight differences between them. Okay, so we are able to establish an identity that cos square x minus sin square x is equal to 1. So we can establish another identity out of it. Take notice of it. Now let's divide through this function by sin square x, cos square x. So hereby cos square x, hereby cos square x, then hereby cos square x. So what we have, cos square x over divided by cos square x is nothing but 1 minus, in cyclic function, sine over cos is tan. The same way, sin over cos is tan. So we say tan square x. So this will be tan square x, and it's equal to, in cyclic function, 1 over cos is sec. So in hyperbolic 2, 1 over cos x will be sec x. So that will be sec square x. So this is another identity that we might take a very good notice of, that 1 minus tan square x is equal to sec square x. So you know the difference. In cyclic function, we say 1 plus tan square x is sec square x. But in hyperbolic, 1 minus tan square x is sec square x. So please, let's take a very good notice of it. So we're able to get our two identity connecting them. Now let's see. When we have cos square x minus sin square x, we know it's equal to 1. Now let's divide through this function by sin square. So we have hereby sin square x, hereby sin square x, and hereby sin square x. So when we're doing cyclic function, we say cos over sine is tan inverse, and tan inverse is cot. So we can say this is cot square x minus sin square x divided by sin square x is nothing but 1. Then when we're doing cyclic functions, we say 1 over sine is cosec. The same way, this one to 1 over sin is cosec square x. So this is another identity that we must take a notice of. So with this and that, we have formed a very good basis to be able to differentiate our hyperbolic functions. So check out my next videos on the differentiation of hyperbolic functions. Please, before you sign on, remember to subscribe to my YouTube channel and click on the notification bell so that anytime I share a video, you'll be the first to receive it. Until we meet again.